All right, the purpose of this little video is to just review a couple things about acceleration. To review, acceleration examines how velocity changes over a certain time period. Okay. The acceleration formula is acceleration is equal to our change in velocity over our change in time. Now remember, you can expand this top part. So if we rewrite it, acceleration is equal to your final velocity minus your initial velocity divided by your change in time. Okay, so let's just look at a question. I want to go to this one. Okay, a bee changes its velocity from -7 meters per second to 2 meters per second over a time period of 3 seconds. Two questions: what is the acceleration of the bee, and how did the bee change its motion? Let's draw a little picture. So here we have our little bee. Let's see. Okay, here it is, little wings. We have our bee and it is moving this direction. We're going to designate left as our negative direction. We're going to designate right as our positive direction. So it's moving to the left in the negative direction at a rate of 7 meters per second, going pretty fast. And then we take a snapshot 3 seconds later, and it is now going, I'm going to draw this arrow this big to kind of represent the 7. Now it is going 2 meters per second in the positive direction. So I want to change my sign over there. Here's our little bee. Okay, so to find the acceleration of the bee, we need to do a formula. Again, this happened over a time period of 3 seconds. So our acceleration is going to be equal to our velocity final minus our velocity initial, all divided by our change in time. Let's see, let me move this so that we can have a little bit more room. So our final velocity is 2 meters per second. Our initial velocity is -7 meters per second. And the time period is 3 seconds. So 2 minus a -7 is the same as 2 plus 7, which is 9 meters per second divided by 3 seconds. 9 divided by 3 is 3. So the acceleration is going to be positive 3 meters per second squared. Okay, so that's our value for acceleration. But now we need to examine, how did the bee change its motion? Well, we got to go back to our little picture. So at first, the bee was going in the negative direction at a pretty large magnitude of speed. And then later it was going in the opposite direction a little bit slower. So it actually did two things. The first thing it did is the bee changed direction. We know this because we went from a negative direction to a positive direction. So there had to be a change in direction, which is a type of acceleration. Now, the second way that the bee changed its motion was that it actually changed how fast it was moving. So it went from, if we're just looking at absolute values, it went from an absolute value of about 7 meters per second. I'm just trying to do the absolute value signs, to a rate of 2 meters per second. So 7 is a greater number than 2. So it was going faster and then it slowed down a little bit. So in addition to changing direction, it also slowed down. You're thinking, wait a minute, we've got a positive 3. That must mean that each and every second it's changing its velocity by +3. Well, this positive is actually also looking at the direction change. So just a couple of things to keep in mind. The best way is just to compare what it's doing at the beginning to what it's doing at the end. And that's how you're able to figure out how the motion is changing. Okay, our next question is, a track runner has an acceleration of 0.0 meters per second squared. And we want to describe the two possible motions of the runner. Okay, So if you have an acceleration of 0, the question is, what does this mean for velocity? Well, your acceleration is 0. That must mean that your velocity doesn't change. The reason why we can say this is because if you look at the acceleration equation, acceleration is equal to velocity final minus velocity initial all over our change in time. To get our acceleration equal to 0, we have to have a 0 value for this numerator. To get a 0, we have to have the same exact number for our velocity final and our velocity initial. If those are the same, let's say they're both 2 meters per second. Let's say you were going 2 meters per second, and then a little bit later you were going 2 meters per second. Well, 2 minus 2 is 0 meters per second, and you divide by 0 by any number, whatever your change in time is, your acceleration is going to be equal to 0. So you can have 0 acceleration when your velocity doesn't change. So if you have a constant velocity, the same value when you end versus when you finish, you will have 0 acceleration. Now, another way that you can have an acceleration of 0 meters per second squared is if you are not moving. Obviously, if you're not moving, you cannot be accelerating either. Okay. What we're going to do now is I want you to hop into your notes. Let's go to page 3. We are going to be focusing on the bottom 2 questions. Okay, so I'm going to give you a little bit of time and I'll actually end the video. But what you're going to do is answer letters F and G. So it says describe the acceleration of an object moving in a circular path at constant speed. This little GIF right here is hopefully helping you visualize a circular path at constant speed. What do you think is happening with the acceleration? The next one, describe the velocity of an object when its acceleration is 0. So get a second to write some notes about that. I'd like each of these to be at least one sentence that is a complete sentence. And that is all we got.